knowledge of .NET. Then we'll go with ASP.NET Core.
Agree.
So actually, if that batch would have been there for you, it would have been the best batch for you. Right. So we'll try to understand what is platform independent. But remember, I already said, cross-platform, I already said you with overview on the top.
Correct.
Open source also, I said modern means what I said, high performance is what. So we are exactly at a stage where we need to understand platform independent. You know something? Before you get into platform independent, uh, do you know what is the exact, meaning of platform? But remember one thing, not necessary platform should be always related to OS. No. This is what my experience is. Like if you say, even in interviews, if they ask what is platform, if you just complete your answer saying that platform
Based on
operating system, there ends your interview. There ends. Is what I find. If he's a real technical guy, he won't leave you until as you don't explain him the correct meaning of platform. That is the reason I started like this.
Okay.
Not necessary platform should be related to always OS. So I'll do one thing for you so that things become easy for us. Let us first understand these two most important terms. I better call like this. Important terms. One, platform, and second, framework. Obviously, ours is core framework only. Though I write framework, my intention is just to make you aware what is framework. What is framework? Okay, chalo. Now let me explain you what is platform. Refer to .png file. Okay, let me give you an idea. See, listen carefully. This is every system's base layer. Okay, that is your hardware. Okay, first layer. On hardware, second layer, I'm saying, second layer, that is operating system. Do you agree with me that for installing operating system, hardware is needed? Hard disk required, RAM required, processor required. The hardware is needed or not?
Yeah, it's required, right?
Not only in laptop, desktop, even in your mobile. Think about Android.
Android, yeah.
You have even hardware in
iOS.
your mobile.
Yeah,
Now
Android.
I can now I simply conclude with this picture only. I'll conclude. Hardware is a platform for OS.
Okay.
Not only hardware is a platform for OS, hardware is a platform even for assembly code. Do you know this assembly code? That is where we write programs using hardware components. That is what they call device driver programming. What they call device driver programming. Example, shall I give example so that you understand easily? It is routine process we do. Just think for a while. Think for a while. The moment you connect a pen drive to your laptop, to your mobile, to your desktop, what happens? The moment you connect pen drive.
It will identify one device is trying to connect to your
But
laptop.
before to it, you'll find something called drivers are installed.
Correct.
Right?
Correct.
When drivers are installed, two situations may come. Sometimes that device may not be suitable for your laptop, for your OS. So you may get a message saying that so and so drive trying to install successfully cannot be installed. So and so drive you cannot use. If successfully drivers are installed, you'll get in notification panel, you'll get a message saying that device is ready to use.
Correct.
And you find immediately what drive is allotted. So now my point is, those drivers which are installed are nothing but programs written in assembly language. That is what you call assembly code. Do you feel only drivers are available for pen drive? No, not at all. Drivers may be available for printer, mouse, keyboard, pen drive, printer, scanner, for everyone. That is the reason why we call that assembly code is hardware dependent. Then I explain, then third scenario, here I talk about C, C++ code. C++ code. What is needed? OS is platform. For C++, what is platform? OS is platform. And then I go with fourth layer. The fourth layer is, I'll compare for you. So that will be easy for you to understand. Here. .NET code. On the other end, I'll write. On the other end, here I'll write Java code. Do you really feel that .NET code do you really feel .NET code can directly run on OS? Highly impossible. Highly. .NET code you cannot run on operating system directly. OS cannot understand .NET code. OS cannot understand Java code. That is the reason here we got one special platform that is called JRE. Yeah. And here you have .NET framework. Doesn't matter whether it is old framework or core framework. Anything is fine. Whether it is .NET framework or core framework. Now the story goes like this. You write a .NET code, hand over it to .NET framework. .NET framework will take the program to OS. OS will run that program on hardware. Now, if I ask you a general point in this architecture, how many platforms are there in this example? How many platforms? Answer is
Two
four.
platforms.
Four.
Four, huh? .NET
Four.
framework and OS and
.NET
hardware.
framework, OS, correct. Hardware, JR.
Okay.
So now imagine if they ask what is platform, you just wind up your answer saying that platform is OS, then it goes wrong. You're not justifying correctly. That is the reason. Keeping this picture in view, this is the definition I would say for platform. What is it? Platform is an environment to develop and to deploy. That is nothing but execute application. This is the technical definition of platform. You're not supposed to say that platform is something related to OS. Completely wrong. You better go remember this picture. Definition becomes easy for you. Two things I'm saying. Two things. Environment to develop, I'm saying, or and to deploy. Either you run or you develop. That is what the meaning. Platform is an environment to develop and to deploy, execute what applications. Exactly same way, what I would say now to define framework. Yeah, framework also. Let me give example for you first. Then you understand example. Then I'll write technical definition so that it becomes easy for you.
Yeah, yeah.
Chalo, right. Assume now. I'm talking. I'm connecting like this. Okay, don't get confused. I'm just connecting. What I'm connecting is writing a program, whether it is in C#.NET, VB.NET, or in ASP.NET framework or ASP.NET core framework, right? Anywhere, whenever you're writing a program, you better call that as you are constructing a program. You are constructing a program. So that construction of program, I will compare with the construction of a building. Ah, okay, let's assume like this. So I want to construct. What do you want to construct? A building. What that construction is, remember 2 points in this. 2 points. Constructing on plain surface and constructing on the building. Means already you have a building available. On that, you are just constructing one floor. But the building is already there. You are just constructing what? One floor. One floor. Construction. What did I say? Plain surface. Means land. Land is there. Land. And second, what I'm saying? Building is already there. Right? Ground floor is already there. On that ground floor, you're going to construct one floor. Now can you say me, general point, can you say me, who will take more time, who will take less time? Who will take more time and who will take less time? Obviously, when I say plain surface, because land is there, I have to come from the basement level. I have to go with, I have to dig pillars. For pillars, I have to dig. Then I have to come with all construction from basement level.
Starting.
Then
Correct.
basement level comes. Then from there, the other stories will continue. So assume for construction of a building on a plain surface, say for example, it takes 1 year. Assume 1 year. Here building is already there. You're just constructing one floor. Say this will take, for example, say it's like 6 months. 6 months. 6 months. And after 1 year, here after 6 months, say for example, here people started staying. I mean, people are staying in that. That building after 1 year has been occupied. Okay. People are staying here. Here also, the floor which you constructed, that is also occupied. People are staying there. Now actual story, you listen. For example, something happened after that people occupied that building, after people staying in the building, after 6 months, 10 months, that is collapsed. Here, the floor where I constructed on a ready-made building, that building is also collapsed. So obviously, if building collapsed, floor is collapsed. Now you just think and say me, where am I answerable and where am I not answerable? Where people will catch me so that I have to explain them regarding that destruction, regarding that collapse, or where people cannot question me. Simple conclusion. This 1 year construction that was on plain surface, the total building was constructed in my supervision. Here we just constructed one floor. Here one floor. I was not there when this building was getting constructed. I was not there. But here, every level of construction, I was very much available. If building collapsed, which I constructed on plain surface, definitely people will catch me. People will question me. I'm answerable to the people regarding that destruction. Whereas that floor which I constructed, that building, if that collapsed, they cannot question me because I was not there when that when that building was getting constructed. That's what we have a concept, like, it's not like every time we have the same process to deal with. Mm. Now, keeping this, did you get me what exactly I tried to convey with this example? Did you understand that? Now I'll explain the definition. I'll write technical definition. Now I'll write, here I'll write framework. What do you call? Ready to use. Yeah. Ready to use. What? Collection of classes and interfaces through which we can develop our application. Now, by looking to this definition or by reading this definition, can you compare that this definition is relevant to which scenario of these two constructions? Which scenario of these two constructions?
Framework is the
Here,
big
building, one
correct,
floor construction.
correct.
It means Microsoft has already provided you ready-made classes and interfaces. Because of that ready-made classes and interfaces, our 60% burden is reduced. Now your efforts are only 40%. That is for your logic. That's what I was saying. Ready to use collection of classes and interfaces using which we are going to develop our own application. That is the definition of what? Framework. Yeah. Now remember one more point. Listen carefully, please. Platform independent. Now, when you're talking about platform independent using core framework, core framework, 100% what we see, 100% what we see is it was platform independent, but it was partially. I'm talking about old framework. I'm talking about .NET framework, where the application developed in .NET, it was platform independent, but partially platform independent. But the platform independent, according to core, remember, you are made available with cross platform. That itself makes us understand that accurate platform independent process has been introduced. Yeah. So is the point what I do instead of making theoretical things and getting confused. Let me put this. I'll come with three architectures on this. Three architectures. Fifth point, platform independent. First, I'll explain architecture of platform independent. Yeah. Here I call refer to .png file. After that, I'll explain you architecture of code compilation and execution process. Yeah, this I'll explain. This also I will refer to .png file. And then we will study something called reverse engineering in .NET. Yeah, this also I'll cover through .png file. Yeah, I don't know whether you're aware or not, but we got something, a special, what do you call, APIs provided by .NET. Let me just show you. What do you call that? Uh, Developer come here command prompt. Yeah, click on. Yeah, what is that? That is called. Have you heard about this? IL DASM. Two things, two APIs. IL DASM, IL ASM. Intermediate language. IL D DIS DIS ASM assembler. IL ASM intermediate language assembler. Yeah, this window you'll get when you say IL DASM. This window, IL DASM. You can call that as API, software provided API. Through that, we will try to understand what is reverse engineering in .NET. Yeah. Even I'll compare, nothing to worry. Even I'm going to compare this. Yeah. Whether .NET Core supports this or not. Framework में तो 100% we used to have. .NET framework, old framework में reverse engineering 100% we used to have. That is the reason why Microsoft has introduced, to avoid reverse engineering, Microsoft has introduced one special tool by a name called .Fuscator. A new tool Microsoft has introduced. Whenever we used to develop application using .NET framework, at that time, that application was not secured. That application was not secured. So for that reason, to provide security for the application, we used to have this tool. The name of the tool was called .Fuscator tool. I'll explain about this tool also. I'll show you. Yeah. Now, to understand what is platform independent, I'll cover here. Listen. First, let me explain you. This is, yeah. Let me call. This is .NET Core application. Yeah. .NET Core application. Where did you write? Whichever you feel. C#, Visual Basic. Yeah. What do you call that? That is what you refer. Source code. After writing program, what would you do after writing program? Obviously, we hand over this program. We hand over this program to whom? To something called language compiler. Yes. If you have written a program in C sharp, give it to C sharp compiler. If you have written a program in VB, give it to VB compiler. Every language will have its own compiler. If I'm writing a program in C language compiler. If I'm writing a program in Java compiler. You give a program to Java compiler. Yeah, depends which language you are using. Hand over the program to that compiler. That is the fundamental process. You understand what I'm saying here, right? Language compiler means
Yeah, I understand.
every language will have its own compiler.
Correct.
And what that compiler will do, this is important. Compiler will generate what? This special file. What do you call this file? Assembly. What they call? Assembly. What will be the extension? Either of them. .exe, .dll. But .NET Core will generate both of them. .NET Core will generate both. Whenever you compile a program of C sharp, you'll have exe and DLL both. Yes. And exe is executable. DLL is dynamic link library. DLL is dynamic link library. And one more, assemblies will be 3 types. Assemblies. What are they? 1, private assembly. 2, public assembly. 3, satellite assembly. We have separate topic on this. Private assembly, public assembly, satellite assembly. 3.
Satellite assembly is nothing but it's a shared assembly.
No, that public assembly is a shared assembly.
Public assembly, the shared
Shared
assembly.
assembly. Satellite assembly is that which contains only resource file, only resource content, that which we actually use when you want to go with something called,
Multi-language purpose.
exactly. Correct. Correct.
Got it.
And one more interesting thing about DLL also. I said DLL. DLL will be of 3 types again. DLL. One they call, one DLL they call COM DLL. COM DLL. And one they call Win32 DLL. And another one they call, that is called .NET DLL. Obviously, ours is .NET DLL. And what do we have in this? What do we have? Remember, this is going to have CIL code. CIL code. Which format it will be? Obviously, binary format. Language compiler generates CIL code in binary format. Yes. CIL code in binary format. And this CIL code, we used to call them by different names in older versions. One name we used to have as MSIL code. It was also called by name byte code. Yeah, we used to call MSIL code, or it was also called by name bytecode. Bytecode. MSIL code, bytecode. CIL is what you why they named actually. Earlier it was called MSIL. Now they called it as CIL, Common Intermediate Language. Do you feel that that assembly will have only CIL code? No, assembly will contain four components. I'll explain. Second architecture, I'll explain. And now the story is this CIL code you hand over now to multiple operating system. Yeah, you hand over it now. To whom you hand over? Multiple operating systems. Who are they? This is one OS. Yeah, this is one OS. This is one OS. And this is one OS. Yeah, three I'm taking example. Three. Yeah. Which OS you're talking about? One, Windows OS. Second, Linux OS. Third, Mac OS. Yeah, Mac OS. Windows OS, Linux operating system, Mac operating. Yeah, three. And for all of them, we are provided by one only component. We are provided by only one component. 1 second. I have a call from office. 1 second.
Yeah, that's fine.
Yeah. So now what they did, now we have, because we are talking about .NET Core. This is what we find today. What we are made available. We are made available. What? Core CLR. Introduction class. Here. Core CLR. Runtime environment. Core CLR. Yes. In .NET framework, we used to have multiple CLRs. I don't know whether you're aware or not. We used to have what CLRs? One, Windows CLR. Windows CLR.
Based
Second,
on the application. Windows
Ah,
application, web application.
Windows CLR, sorry, Windows CLR1,
Uh-huh.
Mono CLR we used to have one. Mono CLR.
Mono CLR we are using for mobile application or
नहीं, Mono CLR for Linux operating system.
Linux support. Okay, okay.
And then we used to have compact CLR. That is for devices, lightweight devices, mobile, swiping machine,
Okay.
pager. For them, we used to have compact CLR. For every operating system, we used to have a separate CLR. And that CLR used to be platform dependent. Today, we find core CLR straight away platform independent because it is common for all. Same core CLR for Windows core, or for Linux core CLR for Mac. But why do you need core CLR here? Reason, because CIL code, which is generated by compiler, operating systems cannot understand. For that reason, that core CLR is introduced. And core CLR will make OS understand that code. What is that code? That is called machine language, is what you call as native code. Yeah. Machine language, or we used to call native code. Yes. Machine language. Machine language. Machine language. Yes. Which code they are making understand which code? Obviously, CIL code. In total architecture, remember, CIL code makes your .NET Core application platform independent. Because same CIL code, we are running it on Windows, we are running it on Linux, even we are running it on Mac OS. That is the concept of platform independent. Core CLR is also platform independent, cross-platform. It is taking this CIL code, this CLR is making Windows understand. Core CLR is making Linux understand. Core CLR is making Mac OS understand. Same CIL code. Yeah, that is what we have a point. Who is platform independent? Answer: CIL code makes .NET application platform independent. Yeah, that's it. Tomorrow I'll explain remaining.